So let's start today's lecture. In the last class, we have discussed about decoders, and now today we are going to discuss about the encoders. As it is clear from the name that the decoder and encoder are both complementary functions. That means we can say that the encoder is the reverse process of decoder. Decoders and encoders are always used in pair in digital systems. With the definition, an encoder is a combinational logic circuit. It performs the inverse operation of the decoder. That means the output of the decoder will be act as input to the encoder, and input to the encoder is the output of the decoder, like this, or we can say that it is a inverse process or the complementary process of the decoder. The opposite process of decoding is known as encoding. An encoder converts an active input signal into a coded output signal. So in case of the decoder, we have a coded input, and at one time only one output was the active. So active may be 0, active may be 1. For logic, for high logic or for the positive logic, 1 is considered as active high, and for negative logic we consider as 0 as a active high or active input. So we can see in the block diagram, next, here it is. We have m number of inputs, n number of outputs, and the relation is again that m equals to 2 raised to the power n. So in case of the decoder, output was m. In case of encoder, input is m and output is n. So an encoder has m input lines, only one of which is activated at a time, and produces an n bit output code depending on which input is activated. So from the block diagram, it is clear that then encoder is doing the reverse process of the decoder, where input and output are totally changed. Encoders are used to translate the rotary or linear motion into a digital signal. The difference between encoder and decoder is that decoder has binary codes as input, while encoder has binary codes as an output. So whatever is the input to the decoder, that will be the output of the encoder. Encoder is an electronic device that converts the analog signal to digital signal, such as BCD codes. And we have different type of encoders. We have priority encoder, decimal to BCD encoder, octal to binary encoder, or hexadecimal to binary encoder. So we have different types of encoder, and depending upon the number of input and the number of output, these are named as different types of encoder. Like octal to binary means if inputs are 8, then it is octal to binary. If the input is hexadecimal, then it is hexadecimal to binary encoder, like this. Suppose this is an encoder, we have m equals to 4, that is 4 number of inputs, then n will be 2, then the encoder will be of 4 is to 2, and with the same, the decoder will be used in conjunction with the encoder, that will be of the size of the 2 is to 4. So we can directly see that whatever code is coded with the help of the encoder at the time of the transmitting information or transmitting a digital signal, the work of the decoder is to decode that particular code and again make it visible to the m number of output lines. So we can say that when we are transferring an information, suppose we have to transmit 4 bit of information and we are transmitting without the help of the encoder and the decoder, then in that case we need at least 4 data line which are between transmitter and the receiver. Suppose this is your transmitter, this is your receiver, and we have this is your channel. Now what happens in that case, we need four data lines, and suppose when we are using an encoder to encode the binary code, then this is encoded to the two outputs. Now in this case we need only two output line or two data line to transmit the information. Again, at the time of the receiving, at the receiver end, this code is again decoded with the help of a decoder, again 2:4 decoder, which will decode two input binary into a four input output by code. So this is the way how the data is encoded and decoded in a computer. So what it does, the benefit of using encoder and decoder is that we can reduce number of lines or number of the patch cords for transmitting of the data. So it reduces the size of your data bus. That is the big advantage of using encoder and decoders. Suppose with the same encoder we have A2 is active, so this switch is closed. We can see here all switch are open. We have closed switch A2. So A2 is closed and the input at the A2 is 1 0. That means this is 1. So you can see in all four combination at a time only one input is activated. Here is no input is activated. 1, it is 2, and it is 3 like this. So this is activated. We have short circuited it. Now the output of the encoder will be 1 0, 1 0. Only one input is activated. Now this output is input to the decoder. It will decode accordingly. Now what will it do? It will show 1 0 at the output. So this data is transmitted with the bus number 3 according to the output of the encoder is encoded. The decoder is used to decode the input signal, and in the same manner data is transmitted. So this is the way switches are open and short circuited. Now the first type of encoder, that is octal to binary, and it is clear from the name octal, that means we have 8 bit of input and 3 bit of output. The relation is again input is 2 raised to the power n and the output is n. So here is we have D0 to D7 number of inputs, 8 inputs. We have X, Y, Z, 3 outputs. So when we are using an decoder, it was just reverse. X, Y, Z, these are the inputs, and D0 to D7 were 8 outputs. So here process is totally changed. It has 8 input and 3 output lines. Only one input has one value at any given time. Each input corresponds to each octal digit and output generates corresponding binary code. We'll see with the truth table. So we have D0, D1, D2, D3, D4, D5, D6 and D7. These are 8 inputs and 3 outputs X, Y, Z. So when D0 is 1, 0, 0, 0 is the output. When D1 is 1, output is 0, 0, 1. For D2, output is 0, 1, 0. D3, output 0, 1, 1. D4, output is 1, 0, 0. D5, output is 1, 0, 1. For D6, it is 1, 1, 0. And for D7, it is 1, 1, 1. So you can clearly see that at any given time, only one input is allowed to be active. And active here in this case is 1. So this must be kept in mind, that at any given time only one input can be 1, and according to that the output is generated. When we solve from the truth table that X is 1 when D4, D5, D6 and D7 are 1. So we can see again from here X is 1 either D4, D5, D6 or D7. These are the 4 combination. If these are the input combination, then the X is 1. Similarly, we can find out Y equals to, Y is 1 when D2, D3, D6 and D7. So in the same manner, we can find out the value of X, Y, Z whenever they are 1. The corresponding input combinations are odd. with the help of OR gate, and we get x equals to d4, d5, d6, d7, y equals to d2 plus d3 plus d6 plus d7, and z equals to d1 plus d3 plus d5 plus d7. So these are the output combinations which are to be implemented with the help of the gate. Now assume that only one input is high at a given time. Now what happens if more than one inputs are 1 due to any mean, if there are fluctuations in the circuit, and suppose that at any given time, for example, D3 and D6 are high. So this may be a noise, this may be a electrical fluctuation, and we have assumed that at given time only one input can be high. Now suppose the case when two of the inputs, suppose D3 and D6 are high. Now what will happen, as D6 is 1, so X will be 1, here D3, D6 both are 1, Y will be 1, here D3 is 1, then Z will be 1. Then the output will be 1, 1, 1, and which is not desirable, because at any moment one input must be high. That means either output should be D3, that is 0, 1, 1, or output should be D6 according to 1, 1, 0. So that means the output should be either 0, 1, 1 or 1, 1, 0, but the output in that case will be encoded as 1, 1, 1, which is not corresponding to D3 nor D6. So this is the major problem with such type of encoders when we are using an encoder and assuming that at any given time only one input is active. Now to overcome this problem, the priority encoders are used, in which the priority of the signal is priority of the bit is assigned. That we are going in the next slide to discuss what the priority encoders are and how they are designed. Now from the truth table, it is clear that output X is 1 if any of the digit D4, D5, D6 or D7 is 1. But in this case, we can say that D0 has no significance. Either D0 is 1 or D0 is 0. That is no effect of D0 on the output combination X, Y, Z. So there are two problems. The first problem is that D0 is don't care condition, which is not included in the output. And the second one is that if two input at a time are 1, then what should be the output? And that is the contradiction of the assumption that we are assuming that in the initial case, one input should be active. And these both problems can be overcome with the help of a priority encoder. So let us first design this circuit. We have X equals to D4 plus D5 plus D6 plus D7, Y equals to D2 plus D3 plus D6 plus D7, Z equals to D1 plus D3 plus D5 plus D7, and we can implement this circuit like this. So here you can clearly see that D0 has no connection to any of the output. So that's an issue which will be resolved when we are discussing in the next slide the priority encoders. So till now it must be clear that an encoder has m number of inputs and n number of outputs. M is 2 raised to power n. At any moment one input is activated, that is high, all other should be 0. And the main problem with this design is that D0 is not considered in any of the output, and there is an ambiguity in the answer when two of the inputs are 1 at any time. And these problems are overruled when we use the priority encoder. So let's discuss what the priority encoder is. As the name indicates, the priority is given to the input lines. We define the priorities at the time of the designing. If two or more input lines are high at the same time, that is 1 at the same time, then the input line with the higher priority shall be considered, and whichever is with the lower priority, that should be neglected. So this is the priority encoder block diagram. We suppose we are designing a 4:2 priority encoder, and we have given the highest priority to the D3, then D2 has lower priority, D1 has lower priority than D2, and D0 has the least priority input. Means priority means whenever D3 is 1, so we don't care about what are the value of the D2, D1 and D0, and according to the D3 the output should be 1, 1 like this. So there are 4 inputs D0, D1, D2, D3 and 2 outputs Y1 and Y2. D3 has highest priority, D2 is the lowest priority in the decreasing order. Suppose D3 is 1, then irrespective of other input, then output should be 1, 1. So this is the process. Here it is wrongly written. It should be Y0, Y1 and Y0. Suppose this is the table. D3 has the highest priority, D3, D2, D1, D0, Y1, Y0 are two outputs, and we have taken another output V, which indicates that there is any valid input. So in the case when it is 0, 0, 0, 0, so we say that none of the input is 1, and we have showed that 0, that means there is no valid input and we don't care about the output. Now come to the last line, we start our table from here. Now suppose D3 is 1. Suppose D3 is 1, that means we don't care about D2, D1 and D0, and in that case the output should be 1, 1, which is written in this line. If D3 is 1 irrespective of other input, then output should be 1, 1. So whenever D3 is 1, we don't care about D2, D1 and D0, and the output is 1, 1, and we say yes, there is a valid input because one of the input is 1. Now come to the above line about this. If D2 is 1, that means D3 should be 0. If D2 is 1, D3 should be 0, and we don't care about D1 and D0. That means whenever D2 is 1, provided that D3 is 0, then the output should be 1, 0. And again, yes, there is a valid input combination because D2 is 1. Now for D1 is 1, when D1 is 1, it should be provided that D3, D2 should be 0 and we don't care about D0, then the output should be 0, 1. Output should be 0, 1, and yes, it is a valid input combination. Now to encode D0, all D3, D2, D1 should be 0 and the output in this case should be 0, 0, and yes, there is a valid input because D0 is 1. So this is how the table is implemented or how the table is constructed. There may be some difficulties in understanding this table, how the table is constructed, because there is no so much theory given in your any textbook that how the table is constructed. So I'll share this video with you all, and if you find out any difficulty, then you can ask me, and your problem will be sorted out. So now what we do, we just expand these don't care conditions. So this X may be either 0 or 1, then it will be extended like 0, 0, 1, 0 and 0, 0, 1, 1. So this X will be extended to the two columns, and for the both column output should be 0, 1, 1. Similarly, these two X's can have four possible combinations 0, 0, 0, 1, 1, 0, 1, 1. And the output for the four combination will be 1, 0, 1, and this 0, 1 will be same. Similarly, this three don't care conditions will be expanded up to 8 different combinations ranging from 0, 0, 0 to 1, 1, 1, and the output will be 1, 1, 1, and D3 will be 1 for all 8 possible combinations. Whenever you expand this table up to 16 combinations, you will get 4 input and 3 output truth table, and we have to solve the expression for y1, y0 and v. So here I have tried to solve the K map. for the y1. So it will look like we have 0, 0, 0, 0 for x. Here we have written the combination 0, 0, 0, 0 is x, and rest of the value I have put it, and I get y1 equals to d2 plus d3. I have two octates. Similarly, we can solve the K-map for y0. It is one octet and one quad, and the output comes y0 equals to d3 plus d2 bar d1. And similarly, we can find out the K-map for v, and which comes to be d0 plus d1 plus d2 plus d3. So in this way, we can draw the circuit diagram, and the circuit diagrams is like this. We have three inputs d0, d1, d2, d3. We have three outputs x, y, and v. And now in this case, you can see clearly that d0 is considered when we are getting the output v. So again, as in the case of octal to binary encoder, there was no use of the input combination D0, but when we are using the priority encoder, there is the use of D0, which will indicate that if there is a prior valid input or not at the input combination. Now the next one is decimal to BCD encoder. As clear from the name, decimal is the input, BCD is the output. So we have 10 inputs corresponding to 10 decimal number D0 to D9, and 4 outputs A, B, C, D, which represents the binary coded decimal. So here is your block diagram of BCD to decimal encoder, 0 to 9, 10 inputs and 4 outputs. Truth table: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can write like A0, A1, A2, A3, A4, A5, A6, A7, A8, A9. Like these 10 inputs, BCD output. Whenever 0 is 1, output should be 0, 0, 0. Whenever 1 is 1, output should be 0, 0, 1. Whenever 9 is 1, then the output should be 1, 0, 0, 1. So input is decimal number, output is BCD. Now from the truth table, it is clear that A is high when input is either 8 or 9. So we can see A is high, this is A, when input is either 8 or 9. So we write it 8 plus 9. Similarly, B is high for 4, 5, 6 and 7. C is high for 2, 3, 6, 7. And D is high for 1, 3, 5, 7, 9. And with this help, we can make the logic diagram. So these are the inputs: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have used a toggle switch. Means whenever switch is closed, the particular input is given. If I press this, that means that this line will be 1 and corresponding D will be 1. The output will be 0, 0, 0, 1. When I put 2, all other will be 0. By pressing 2, this line will be 1. Then I get 0, 0, 1, 0. That is 2. Like this. In this manner, we can find out the corresponding BCD code. So the next topic is multiplexers and demultiplexers. I think we should stop today's lecture here, and we'll discuss it in the next lecture. That will be your last topic to the unit 1. And for the practice, you write a question, construct hexadecimal to binary encoder. You have to design it with yourself. For the hexadecimal, the inputs will be 16, 0 to 9, and A, B, C, D, E, F, and the output will be 4-bit A, B, C, D. In the same manner, what we have designed the decimal to BCD encoder, the same way you have to design a hexadecimal to binary encoder. If you have any doubt about this lecture, then you can contact me. Then I will try to sort out your doubts.